Welcome everyone to today's Explainer. Today we're tackling a topic that, honestly, sounds incredibly intimidating at first, machine learning in Python. But don't worry, we're going to break it down into really simple, logical pieces together. You absolutely do not need a PhD in computer science for this. We're going to demystify one of the most powerful tools in modern programming, so let's get right into it.
So you have data, but how can you teach a computer to actually find patterns and make predictions from that data? That right there is literally the core problem of the 21st century. We are drowning in data, right? Sales numbers, customer clicks, weather patterns, you name it. But raw data on its own isn't smart. To turn that raw data into actual predictive intelligence without spending months writing complex mathematical algorithms from scratch, you need a very specific solution. And that solution is Scikit-learn.
Okay, let's dive into this. Here is our roadmap for today. First, we'll meet your ML toolbox. Then, we'll look at core machine learning tasks, build your first model, talk about training and testing data, cover best practices and evaluation, and finally, wrap things up with the complete data workflow.
All right, Section 1, meet your ML toolbox. Let's get a quick introduction to Scikit-learn.
So Scikit-learn, which you'll often hear developers just call sklearn for short, is an incredibly popular open-source Python library. But what does that actually mean for you? Well, it means you do not have to be a math genius to do machine learning. This library does the heavy lifting for us. It provides you with ready-to-use, prepackaged tools for training models, making predictions, cleaning up your data, and evaluating how well your model is actually doing. The really complex algorithms, they're already built, they're fully tested, and they are just waiting for you to use them.
The best way to understand this is to think of Scikit-learn exactly like a literal machine learning toolbox. Think about it. If you need to build a shelf, you don't invent a hammer from scratch, right? No way! You grab a hammer from your toolbox. Scikit-learn works the exact same way. You just choose an algorithm from the box, hand it your data, tell it to train, and suddenly you have a machine making predictions. It makes that massive conceptual leap from raw numbers to artificial intelligence completely accessible to anyone.
Moving right along to Section 2, Core Machine Learning Tasks. What can this thing actually do?
Well, here are the major machine learning tasks Scikit-learn supports, all with a wonderfully consistent interface. First up, we have classification. That's predicting categories, like deciding if an incoming email is spam or not spam. Then regression, predicting continuous numerical values, kind of like guessing the price of a house based on its square footage. We also have clustering, which is grouping similar data points together without even knowing what the categories are in advance. But Scikit-learn isn't just about algorithms, you know. It also handles preprocessing to prepare your messy real-world data, model selection to help you tune things to perfection, and model evaluation to actually grade your model's performance. It's a true end-to-end toolkit.
And this brilliantly illustrates the overall journey of pretty much any machine learning project. We always start with step 1, the raw data. Then we move straight into step 2, training, where we feed that data into our Scikit-learn algorithm so it can learn all those hidden rules and patterns. Once the model is fully trained, we hit step 3, prediction, where we ask it to make guesses on entirely new information. And finally, step 4, evaluation, where we score the model to see how smart it really became. That flow right there, data, training, prediction, evaluation, is the absolute heartbeat of Scikit-learn.
Okay, Section 3, building your first model. Let's take this from theory straight to code.
First things first, how do we actually get this onto our computer? There's a really important technical distinction to catch here. To install the package onto your machine, you run pip install scikit-learn. However, when you're actually writing your Python script and you want to use the tools, you import from the sklearn namespace. So for example, to grab our linear regression tool, we just type from sklearn.linearModel import linear regression. It's a tiny little quirk, install the scikit-learn, import it as sklearn, but knowing this up front saves every beginner a massive headache.
Let's actually slow down a bit here and look at an entire machine learning workflow in just 4 conceptual steps. Step 1, we create our data. We have X for our inputs and Y for our outputs. Just imagine X is our studied and Y is the final test score. Step 2, we create our model. We just type model equals linear regression. We literally just pulled the tool out of the toolbox. Step 3 is where the actual learning happens. We type model.fit x, y. That .fit command is you directly telling the computer, hey, look at these inputs and outputs and learn the relationship between them. And finally, step 4, we estimate the output with model.predict parentheses 6. We're asking the model, if I study for 6 hours, what will my score be? The computer takes that relationship it learned in step 3 and hands you a brand new prediction. It's incredibly elegant when you see it in action.
That brings us to Section 4, Training and Testing Data. Let's talk about splitting the data set.
Now, there are two absolutely crucial concepts we need to separate here. Training data is the data you feed to the model so it can learn the patterns. Testing data, on the other hand, is used to check how well the model performs on completely unseen data. Evaluating a machine learning model on the exact same data it was trained on is a massive pitfall. Why? Because the model might just memorize the answers instead of actually learning the underlying patterns. It's exactly like giving a student the actual answers to a test the night before. They didn't learn the subject, they just memorized the cheat sheet. We must keep our testing data hidden until the very end to get an honest grade.
So how do we actually enforce that separation? Well, Scikit-learn handles this split for us beautifully with just a single line of code. We use a really handy function called train-test-split. We hand it our x and y data, and we just tell it test size equals 0.2, which simply means, hey, hold back 20% of this data for testing and use the other 80% for training. In one single line, Scikit-learn shuffles and deals out 4 perfectly organized sets of data for us: xtrain, xtest, ytrain, and ytest.
Now, what's really interesting about this is it's kind of like a menu for your new toolbox. These are some of the most popular algorithms available to you in Scikit-learn. If you need to predict continuous values, you grab linear regression. Need to sort things into categories? Grab logistic regression. Want a model that makes decisions based on a series of rules? Try a decision tree. Or even better, combine a bunch of them together into a random forest. Want to group data points that look alike? Use k-means. The true beauty of this library is you can seamlessly swap these algorithms in and out of your code using that exact same .fit and .predict structure we just learned without needing to dive deep into the dense mathematics behind them.
All right, Section 5, Best Practices and Evaluation. Basically, checking your work.
Here's a hard truth. Real-world data is almost never clean. It's messy, it's scaled weirdly, and it definitely needs preparation. That's exactly why Scikit-learn provides built-in pre-processing tools like Standard Scaler, which neatly scales your data so algorithms can digest it properly. But once your model makes its predictions, how do you actually know if they're any good? Well, you need specific vocabulary to evaluate your success. That's where evaluation metrics come in. For classification, we use terms like accuracy, precision, and recall to measure how often we were right. For regression, we use mean squared error, or R squared, to measure how close our predicted numbers were to the actual numbers. And yes, Scikit-learn has built-in functions to calculate all of these for you instantly.
Let's do a rapid-fire rundown of common machine learning mistakes so you can completely avoid them right from day one. Number 1, as we just discussed, training and testing on the exact same data. Just don't do it. Always split your data. Second, skipping necessary pre-processing. If your data's a mess, your model will be a mess. Garbage in, garbage out, right? Third, choosing the wrong algorithm. You definitely don't want to use a regression tool for a classification problem. Fourth, ignoring class imbalance. If your dataset is 99% pictures of cats and 1% pictures of dogs, your model is going to have a really hard time learning what a dog actually looks like. And finally, evaluating with an inappropriate metric. Using these best practices right out of the gate will set you miles ahead of the curve.
Finally, Section 6, the complete data workflow. Let's put it all together.
This is basically the holy trinity of the Python data science ecosystem. These libraries work together flawlessly. You start with pandas to load, clean, and manipulate your raw data tables. Then you use matplotlib and seaborn to visualize that data, creating gorgeous charts to really understand what you're looking at. Finally, you hand that clean, well-understood data over to Scikit-learn, which steps in to perform the actual machine learning, training the models and making the predictions. Scikit-learn doesn't try to do everything. It focuses specifically on being the absolute best at machine learning, completing your workflow perfectly.
And just like that, we've reached the end of our journey today. Now that you have the powerful tools to prepare data, train models, and evaluate results, what will you build with Scikit-learn step by step in your next lesson? You now fundamentally understand what this library is, why it exists, and even the exact code to make a model learn and predict. The toolbox is sitting right in front of you, wide open. So the only question left is, what problem are you going to solve next? Thank you so much for joining me in this explainer. Keep learning, keep experimenting, and I absolutely can't wait to see what you build.